Welcome to EDU World Space.
So in this video, we're going to talk about question 108 from chapter 20, which says many structures of phosphorus-containing compounds are drawn with p equals 0 bonds. These bonds are not the typical pi bonds we've considered, which involve the overlap of two p orbitals. Instead, they result from the overlap of a d orbital on phosphorus with a p orbital on oxygen. This type of pi bonding is sometimes used as an explanation for why H3PO4 has the first structure below rather than the second. So in the first structure, we have a double bond to an oxygen, while in the second, we put a lone pair of electrons on the central phosphorus atom. So presumably, it's the overlap between a p and a d orbital that forms this pi bond, this double bond between phosphorus and oxygen in the first structure. And then we're asked to draw a picture showing how a d orbital and a p orbital overlap to form a pi bond. So before we do that, I've drawn p and d orbitals for you to look at first. So our p orbitals are a set of dumbbells aligned along the x, y, and z axes. Our d orbitals, on the other hand, are sets of two dumbbells that are staggered with the axes. So they're diagonal rather than aligned up and down and across. And they're, since we have two sets of them, they're in a plane, in the xz plane, the yz plane, or the xy plane, rather than just aligned along one axis. So how can we draw these overlapping? Well, we have our p orbital, which is straight up and down, and our d orbital, which is staggered or tilted on a diagonal, and they overlap like this.